Today we will be using the metric measurement system and taking a look at the different units that we have for it. We either are dealing with length, mass, or capacity. And so in length, we're going to be taking a look at millimeters. And a millimeter, again, it talks about the benchmark here, thickness of a dime. Centimeter is the width of your little finger. The meter is about the width of a doorway. Kilometer is the length of 10 football fields. And then we're going to be dealing with mass. And mass is kind of like weight. And so when we're dealing with weight, we've got three main ones that we look at. And we look at milligrams. And milligrams are about the mass of a grain of sand. Very, very light. And then we have grams, which are about the size or the weight of a small paperclip. Then we have the kilogram, which is the mass of a textbook. So these are the common ones that we end up using. Even though we could have different prefixes in front of the gram, we use these ones mainly. And so in capacity, we're talking about volume, and so or what something can be filled with. And so milliliter is a common one we see, and that's the amount of liquid in an eyedropper, not very big. And then a liter, well, a liter makes about a large bottle of water. And a kiloliter is the capacity of 2 large refrigerators. And so these are the ones we're going to look at. Again, the main base units are either a meter, a gram, or a liter. And then we use these different prefixes to give us a better understanding about those units. So in the first part of today's lesson, it's going to ask us to choose the most appropriate metric unit for each measurement, and then we're going to justify our answer. So the justifying is going to be used with the benchmark. So these words that we used for the benchmark, these are the same words that we're going to use to justify our answer. So let's take a look at our first one. It talks about the capacity of a paper cup. So let's go up to capacity here, and if I look at kiloliter, that's 2 large refrigerators. Well, that's way much bigger than a paper cup. And the amount of water in a large water bottle, well, that's more than a paper cup too. So I want to go with something smaller than these two. So I would end up going with the milliliter. So I'll abbreviate that, and I'll give my explanation here. And that would be that it would be many eyedroppers. It will be many eyedroppers, but a liter, which is the next unit larger that I would end up wanting to use, is larger than a paper cup. So I want to go with something that doesn't give me something too much bigger than what I'm dealing with. So that's why I'd go with the next unit smaller, even though there's going to be lots of milliliters to make up the amount of capacity in the paper cup. Because the paper cup is going to be smaller than a large water bottle, I'm going to go with the milliliter. Now, a mass of a small poodle. Well, I go to mass, and I'm either going to use a milligram, which is the weight of a grain of sand, so that'd be too light. A small paper clip would be a gram, that's still too light. So the mass of a textbook, that is about what a small dog would be. And even if it were a large dog, I'd still have to go with the kilogram because I wouldn't want to use the weights of a paperclip to compare it to that dog. And so since the small poodle is somewhat close to the kilogram, I would go with this. So we would say something to the effect of equivalent to the weight or mass of a few textbooks. So again, the justification comes in using the verbiage that we used for our benchmarks. So the width of a computer screen, well, looking at my computer screen, looks to be probably a little bit less than maybe like 20 or so, maybe a little more than that, maybe 50 centimeters or so, maybe even longer than that, maybe all the way up to, depending on how big your computer screen is, maybe closer to 70 centimeters. But I would end up using centimeters rather than meters. And here's why. If we look at those lengths, meter is the width of a doorway. Well, my computer screen fits through a doorway, so I wouldn't want to use meters. But even though it's going to take lots of little fingers to make that width from one end to the other end, I would still go with centimeters. And the main reason is, again, it will be several centimeters, but the computer screen is smaller than the width of a doorway. So I've got to give some explanation, and using the benchmarks helps us write that explanation. The mass of a pencil. Well, we go to mass, and as I look at it, well, the textbook's a lot heavier, so I wouldn't want to use kilograms because this is too heavy. So I'd go with the next one smaller. Wouldn't want to use a grain of sand either, but a paper clip's pretty close, so I'd go with just a gram. And so I would say that it would be several small paper clips. Several small paper clips is equivalent to the weight of a pencil. Now we're dealing with thickness. So thickness is length. And so now I need to go to the length, and I'm dealing with either meters, centimeters, millimeters, or even kilometers. But now I'm just dealing with a piece of spaghetti. So spaghetti is pretty small, so I would go with the thickness of a dime. That'd be pretty close to the thickness of a piece of spaghetti, depending on the type that you're dealing with. It might be 1 or 2 thicknesses of a dime. So I would go with millimeter, and the main reason it is close to the thickness of a dime. Well, let's take a look at our next one. It talks about the capacity of a small sink. Well, we have a milliliter, but that's a lot of eye drops. So we go to the next one bigger, and this one talks about a large water bottle. This is the one I would go with because a small sink is going to be a lot smaller than 2 large refrigerators. So even though it might be a few water bottles, that's the one I'd go with. I wouldn't want to go with the one that is bigger because then it would be a fraction of an amount, and it's harder to understand. So I would go with the liter. And it would take a few large water bottles to fill the sink. And so that's why I'd go with that, because it's close to that amount. The mass of an envelope. Well, an envelope is a piece of paper, holds paper in it, and it's not too heavy. And so when I'm looking at mass, I'd go something heavier than the grain of sand, because it would take lots of grains of sand to make the weight of that. But if I look at the mass of a small paper clip, that's pretty close to an envelope. So I'd go with the gram. And again, it would take probably a few small paper clips to be equivalent. And equivalent just means equal in weight. And the mass, or the capacity of a gas truck. Well, capacity, we're dealing with volume, or what it encompasses. And here we have the amount of a liquid in an eyedropper. Well, definitely not that, because this is the gas truck, so this is going to be quite large. A liter is the size of a water bottle, so we want something bigger than that. So I'd go with the kiloliter. And even though the kiloliter is only 2 small refrigerators, it would take many refrigerators, many kiloliters, to be able to fill this gas truck, but that's what we'd end up going with. So let me fix that. Instead of grams, it's going to be kiloliters. And it would take many large refrigerators. So that's the first set of problems that you're going to end up experiencing. The next set of problems is going to ask us to change or compare some different units. And so we're going to have to do some unit conversions. And we'll take a look at that in the next part. So check part 2.